Welcome back, pre-calculus. We're on lesson 1.5. We're finally going to get to our examples. We're going to be graphing transformations of all those parent functions we just reviewed. And the first set of transformations we are going to review are vertical and horizontal translations. So first of all, remember for vertical translations, we're messing with the y value. So it affects the y value of our function points. And notice it's outside of my function. I've either got a plus k or a minus k. If it's positive, it does exactly what it says. It's going to go up k units. If it's negative, it's going to go down k units. For our horizontal transformation, remember that's when the transformation is occurring inside the function. There it is, inside the function, and it does the opposite of what it says. So if h is a positive number, it's going to go to the left. And if h is a negative number, it's going to go to the right. So it does the opposite of what it says. So let's do a couple of graphs to remind ourselves what these look like. So first it says use the graph of the absolute value function. Well, the absolute value function normally looks like a V, shape centered at the origin. Kind of got off there. All right, that's my parent function. I'm going to graph the transformation in, let's say, purple. So purple says, all right, my transformation here is +4. It's outside of the function, so it's going to be a vertical shift. And we're going to shift it up 4. So I'm going to take the center point and move it up 1, 2, 3, 4. And then it's up 1 over 1 from there in both directions. And I'm going to connect those dots. Now, in Algebra 2, you probably were really familiar with making tables and using those tables to transform numbers. We're going to get much quicker with it in pre-calculus, where we're just going to shift the whole thing as is, especially for these rigid transformations. We don't really need a table to help us. We want to get to a point where we can do it without a table. All right, for B, again, my parent function is a V centered at 0, 0. Now our transformation is occurring inside the function, so it's going to be a horizontal transformation. It says +3, which means I think we want to go 3, but remember, horizontal, they do the opposite of what it says. So instead of going to the right 3, we're going to go to the left 3. So I'm going to go 1, 2, 3 to the left, and that's where I'm going to start my transformation, or start my function. We're going to go up 1 over 1, and once we get a couple of good points in there, we'll connect the dots, and there we go. All right, C's parent function, again, is the absolute value. How do I know? Because I see those absolute value symbols. So I'm going to draw my parent function in the green. And let's do a transformation in a blue color. All right, this has two transformations happening. First of all, inside the function, I've got a -2, which means instead of going to the left 2, because it's horizontal, we're going to go to the right 2. And then outside of the function, I've got a -1, which means we're going to go down. So from this vertex, I'm going to go to the right 2 and then down 1. And this is going to be my new center point for my absolute value. And we're going to go up 1 and over 1, both directions. Once we have a couple of good points, we connect the dots. And we have our transformation. All right, go ahead and pause your video, see if you can do these. What's your parent function for this one? I'm not telling you, see if you can figure out, and pause the video and come back when you think you have it. All right, welcome back. Hopefully you said, well, my parent function is this cube. So my parent function is x cubed, which is a cubic function. Our normal cubic function goes to the center 0, 0, and then 1 cubed is 1, -1 cubed is -1, and we kind of have an S shape that goes through there. Don't have to be terribly precise with it. All right, for this one, we're outside of the function. It's -5. That means we're going to go down 5. So I'm going to go 1, 2, 3, 4, 5 down, put a dot. There's one point, here's the other point, and I'm going to make an S that's going through them. All right. Again, a cubic function for B. It normally goes through these 3 points for our parent function. Oh, this one curved a little bit too much back. Didn't really intend for all that. Try that again. How about that? Looks a little bit better. All right, and then for our transformation, we're inside the parentheses. It says -3, which indicates left 3, but instead, because it's horizontal, we're going to go right 3. So 1, 2, 3 to the right. That's going to be my center point. Up 1, down 1, and over 1. And that gives me my nice points to make my S with. And one more. Again, we're inside the parentheses. We're going to go not to the right 2, but the opposite. We're going to go to the left 2. Outside the parentheses, we say exactly what it says. We're going to go up 4. So we're going to go to the left 2, up 1, 2, 3, 4, and we get right here. Up 1 over 1, down 1 over 1. Whoops. Let's draw our parent function first. Here's our parent function. And we'll do a different color for this one. This is our transformed function. And there we go. Like I said, it didn't have to be terribly precise. As long as we have some good points that we're working off of and I can tell it looks like a cubic, you'll be good.